In this video, we're going to go over some machine learning concepts and algorithms. So this is very important for you to be able to understand here because we're going to be working obviously a lot with machine learning. We're going to be writing some algorithms here. We're going to be able to understand really what this whole thing is all about. And in order for us to be proficient with machine learning, it's important for us to understand these key concepts and these various algorithms so that you'll be, ready to go and fully understanding what you're doing when we're going to be writing the code and creating the different algorithms, right? So let's go ahead and jump into the machine learning concepts and algorithms. So the elements of machine learning, let's look at those. There are thousands of machine learning algorithms, and every machine learning algorithm has three components, okay? So very important here for you to understand this, that with the thousands of various different machine learning algorithms, they all have these three components, right? So number one here, representation, decision trees, having different sets of rules, instances, right? Graphical models. It's essentially how you're presenting the information, right? Different neural networks, support vector machines, right? All of this is essentially how you're representing the data, right? So the next one here, the evaluation. This is where we evaluate the different candidate programs, right? Through various hypotheses, right? So example, accuracy, prediction, recall, likelihood. This is where we're using, probability, cost, margin, all of that. So we're evaluating the information to make sure that it makes sense, right? And then we have optimization. So ultimately, optimization is about improving, right? Being able to look at what we currently have and being able to find ways of improvement or different things that can be improved upon, right? And then all machine learning algorithms are a combination of these three components, right? Just like I mentioned, you're always going to see this, and we're going to be able to walk through this in this course numerous times when we're, being able to work within data, work with different, data sets, and be able to find the key insights, right? We're going to be using these three elements. And then machine learning algorithms by learning method. So first thing here we have is the supervised and inductive machine learning method, right? And this is data that includes desired inputs and outputs. You can see on the right hand side there, input data is called training data and has a known label or result such as spam, not spam, or stock price at a time, right? Or a stock price. So just think about if you're sending email, right? And it's either going to be in the spam or it's not going to be spam, right? And a model is prepared through a training process in which it is required to make predictions and is corrected when those predictions are wrong. So the training process continues until the model achieves a desired level of accuracy on the training data. So this is really about the supervised type of learning here, right? We're easily able to understand, based off of the inputs, what we're looking to accomplish. Is something, spam, is something not spam, right? And then we have the unsupervised. So this is where the data does not include a desired input output, right? So with the particular supervised learning, right? The supervised learning method has the actual inputs and outputs, right? With the unsupervised, we don't have any of that. So we're essentially, working with something from scratch, right? A model is prepared by deducing structures present in the input data. This may be to extract general rules and maybe through a mathematical process to systematically reduce redundancy, or maybe to organize data by similarity. So that's going to be the supervised and then unsupervised and then the semi-supervised. This particular data includes some desired outputs, right? There is a desired prediction problem, but the model must learn the structures to organize the data as well as make predictions. So notice how you have the supervised and then the semi-supervised where you have an output. With the unsupervised, you don't have anything. And so you're using different mathematical, formulas, processes to be able to understand what the actual output is going to be, right? So very important to understand the, various machine learning methods, right? And so now let's go ahead and dig in a little bit deeper into supervised learning. So machines often learn from data that has both an example input and an example output. Here's an example. So one data sample pair has an input data about an individual's credit history, right? Their credit score, their credit background, their credit report, right? And the output is the corresponding credit risk, okay? So given enough of these input and output samples, the machine learns how to construct a model that is consistent with these samples it trained on, right? Just like I was mentioning the example of when you go out and you are looking to get a credit card, you're looking to get credit out there, right? You're going to be filling out an application and you're going to be putting in certain types of information about yourself, about your income, your job, right? Maybe your area that you're living, your location, right? All of these different things. And then given enough of these input and output samples, the machine learns how to construct a model that is consistent with the samples it trained on. So this is extremely powerful here. And this is what really supervised learning is about. And this is probably one of the best types of learning methods because you are able to be on top of it, right? It's supervised. It's making sure that you have a certain set of criteria, data points, right? And it's able to learn on its own through that particular setup there. So from there, the model can be applied to new data that it has never seen before. And in this case, the credit histories of new individuals, right? Powerful. So you've been able to show the algorithm, let's say 100 different profiles, right? And all those different 100 profiles have certain information, certain criteria that trains the model that, hey, this is a good credit individual here, or this is somebody who is not a good credit individual, right? This person has, good quality score, good credit score. This person has a negative score or a bad score. So based off of all of those 100, data points there, those applications that have gone through, the machine has learned what exactly to do as far as the criteria and, which individuals to place on the decline and which individuals to place on the approve, right? So it's very powerful, right? Because it learns this particular information and this criteria, and it's learning it all from the sample data that you've input in there. And then the model applies what it has learned to the real world. Now it's able to be on the bank's website, and it's able to take in applications and be able to make decisions, right, within a matter of seconds. And then, you're able to have somebody actually physically look at the information, but it's all programmed through the machine learning algorithm. This class of machine learning is called supervised learning because the desired predicted outcome is given and the model is supervised to learn the associated model parameters. So this is essentially the supervised learning method here. Now let's go to the supervised learning problem, which is the classification, okay? So the goal of a classification problem is to determine what group a given input belongs to. So we can see here on the right-hand side, we have some images here of a couple dogs and a couple cats. And so what we're looking to do here is understand how to be able to get the machine learning algorithm to classify the right type of animal, right? So for instance, a medical case where the possibilities are disease present, where there's a disease that is present or not present, right? And then the other example, like I mentioned, about having the dogs and the cats, right? And being able to classify them in the right group. And so the machine is trained on data with many examples of inputs, right? Like the image of an animal along with the corresponding output, right? And then it's often called labels, like a cat or a dog. So what we do is we train the model with 1 million or so pictures, right? A ton of images of dogs and cats. And then after that, it should be able to classify a picture of a new dog that wasn't in the training data. So you notice here on the right hand side, we have 2 different types of dogs, 2 different types of cats. And so when we put in there and we, put in through a lot of the different images, let's say millions of different animals as far as dogs and cats, the output is going to be able to show us and showcase, yeah, this is actually a dog based on the classification, the information, the data that, we've learned from all those million images, right? So that's why it's extremely powerful here with the classification. And so now let's look at regression, okay? So like classification, regression is also about inputs and corresponding outputs. So here we have a bunch of, individuals here. We have men that are, young men. We have men that are older. We have middle-aged men here, right? So outputs for classification are typically discrete types, right? Think about a cat or a dog, or think about a man or a woman, right? Outputs for regression are general number. The outputs for regression are a general number. So in other words, it's not a 0 or a 1, but a sliding scale of possibility. A good example here is to think about an X-ray image, right? A model could predict how many more years the associated individual will be sick for or healthy for, right? Based on a specific X-ray image. Or for this example here, just think about that it's looking to categorize whether somebody is, middle-aged, whether somebody is 18 years old, kind of maybe a teenager getting into the young adult years, or somebody's, 50 years old, which is like a boomer, right? Baby boomer, or whether somebody's like a senior citizen who is, 80 plus years old. And so it's able to spit out a certain prediction based on the certain parameters, right? So very, very powerful as well. And so now let's take a look at the unsupervised learning clustering. So in unsupervised learning, the machine learns from data for which the outcomes are not known, right? It's given input samples, but no output samples. So if you look at the image there to the right, we have, all the different squares and the circles, and then they are clustered, in two different clusters based off of how many squares and how many circles. So it's pretty much, set up there where it's able to classify them and cluster them into separate groups. So let's say you have a set of documents that you're looking to organize, right? Some documents may be about sports, other about history, others about different arts or games or whatever that may be, right? Given only the set of documents, the objective is to automatically learn how to cluster them into types. So let's say you have, a bunch of squares, circles, and maybe you have triangles, maybe you have ovals or, different types of shapes. The clustering is going to place them in those individual groups, right? For clustering, only the input, right, the data one seeks to organize is provided. So we have the squares, the circles, or whatever that may be. We have that information, but we don't have the output, right? So no output is provided. The model may cluster in the sports documents in one group and the history documents in another group, but it will never be told explicitly what a sports or history document looks like, as it was never shown sample output data, right? It's just going to be able to classify them, based on whether they're, a square or a circle, but it's not really looking at the actual data itself, right? Because it doesn't have sample output data to work with. And so once clustering is complete, the model still won't know what a sports or history document is. All the model knows is that the inputs in group A are similar to each other and the outputs in group B are also similar to each other, right? And so it's up to us to look at the clusters and decide whether and how they make sense. So this is essentially what clustering is all about. And then we have the semi-supervised learning. So the semi-supervised learning is a combination of supervised and unsupervised learning, right? Very simple explanation there. And then it uses a small amount of labeled data and a large amount of unlabeled data, which provides the benefit of both unsupervised and supervised learning while avoiding the challenges of finding a large amount of labeled data. So look at the image over here on the right hand side. You can see the unlabeled data is pretty much jumbled up. It's all, together there, and we want to be able to make sense of it. And then we have the labeled data that is, precisely in a nice row. It's, labeled precisely exactly what the information is, what the data is, right? But it's not set up and classified in a particular manner, right? This approach to machine learning is a combination of supervised machine learning, which uses labeled data, and unsupervised learning, which is the use of the unlabeled data, right? So you have supervised and unsupervised. You're using essentially combination of both, right? This means that you can train a model to label data without having to use as much labeled data. And so this is a quick explanation here of the different types of supervised learning, unsupervised, semi-supervised, supervised learning, right? And so this is really giving you an understanding of the different concepts, the algorithms, different things that we're going to be doing within this course through the machine learning area, machine learning section. So that's going to be here for this one, and we'll see you on the next one.